When you think of an ancient pagoda, what comes to mind? Maybe a delicate wooden structure, or perhaps something built from stone and brick? But what if I told you that one of China's most iconic pagodas, standing for nearly 1,000 years, holds the secrets to an advanced metallurgical technology that rivals modern engineering? Today, we're stripping away the myths and diving deep into the incredible science behind the Iron Pagoda of Kaifeng. Now here's the first big secret. The Iron Pagoda isn't actually made of iron. I know, confusing, right? Its name comes from the lustrous, iron-like color of its glazed brown bricks that have gleamed under the sun for centuries. But the real engineering marvel isn't what's on the outside. It's what's hidden within. This isn't just a stack of bricks. It's a sophisticated pre-modern skyscraper designed to conquer time, gravity, and even the Earth itself. To understand its genius, we need to travel back to the year 1049 during the Northern Song Dynasty. Kaifeng was the bustling capital of the empire, a center of innovation and culture. The emperor ordered the construction of a new pagoda on the site of a previous, one that had been struck by lightning and burned down. The builders, having learned a harsh lesson, decided to create something far more resilient. They didn't just rebuild, they re-engineered. The result was the Youguo Temple Pagoda, the structure we now call the Iron Pagoda. Standing over 57 meters tall, its 13 stories taper elegantly towards the sky. From a distance, it looks solid, almost monolithic. But up close, you can see it's covered in more than 50 different types of intricately carved glazed tiles, depicting everything from celestial guardians and musicians to majestic dragons. It's a work of art, no doubt. But the art is just the beautiful skin on a skeleton of pure engineering brilliance. So, what's the secret to its longevity? It's survived devastating floods of the Yellow River, powerful earthquakes, and the ravages of war for nearly a millennium. The answer lies in a revolutionary construction technique that was centuries ahead of its time, an internal cast iron core. Think of a modern skyscraper. It has a steel frame that provides structural integrity, allowing it to flex and sway without collapsing. The builders of the Iron Pagoda had the same idea, but nearly 1,000 years earlier. Deep inside the brickwork, they embedded a sophisticated system of cast iron braces and interlocking joints. This wasn't just a few random pieces of metal. It was a fully integrated structural skeleton. Let's break down how this high-tech system worked. The core of the pagoda is a solid brick column. But as the builders laid the bricks for each floor, they meticulously incorporated cast iron components. These weren't simple rods. They were complex, custom-made pieces that functioned like a three-dimensional puzzle. There were vertical supports that transferred the immense weight of the structure downwards, and horizontal beams that tied the outer walls to the central core. This created a composite structure, a hybrid of masonry and metal. The brickwork provided compressive strength, bearing the massive load, while the iron framework provided tensile strength, the ability to resist pulling and bending forces. This is the same fundamental principle behind modern reinforced concrete. The Song Dynasty engineers were, in essence, pioneering a form of reinforced masonry. But the real genius is in the joints. The iron components weren't just stacked on top of each other. They were designed with intricate mortise and tenon-style connections. One piece would have a projection, the tenon, which fit perfectly into a corresponding cavity, the mortise, in another piece. This ancient joinery technique, usually associated with woodworking, was masterfully adapted for heavy metal casting. Why is this so important? These interlocking joints allowed the entire iron frame to act as a single, cohesive unit. When an earthquake strikes, the ground shakes violently, sending shockwaves through a building. A rigid structure would crack and crumble under this stress. But the Iron Pagoda was designed to be resilient. The interlocking joints allowed for micro-movements between the components. The structure could flex, sway, and absorb the seismic energy without catastrophic failure. It was a giant, expertly engineered shock absorber. Imagine the pagoda during a tremor. The force travels up the structure. Instead of meeting a rigid wall, it encounters this flexible iron skeleton. The joints shift slightly, the iron beams bend just enough, and the energy is dissipated throughout the entire framework. The outer brick shell is held firmly in place by this internal system, preventing it from shaking apart. The pagoda literally dances with the earthquake and remains standing. This level of metallurgical and structural understanding in the 11th century is simply mind-blowing. The Song Dynasty was a golden age for science and technology in China, and the Iron Pagoda is one of its greatest monuments. They had developed advanced blast furnaces capable of reaching temperatures high enough to melt iron ore and cast it into these complex shapes. This required precise control over fuel, airflow, and metallurgy to create iron that was strong but not brittle. Furthermore, the design of the pagoda itself is a masterclass in aerodynamics and structural stability. Its octagonal shape is inherently more stable than a square, and the gradual tapering of its 13 stories lowers its center of gravity, making it less susceptible to toppling over from wind or seismic forces. Each of the overhanging eaves on every floor isn't just for decoration. They help to break up wind forces, reducing the pressure on the main structure. So let's put it all together. We have an external layer of beautiful, durable glazed bricks that protect the interior from the elements. Inside, a solid masonry core provides compressive strength. Embedded within that core is a revolutionary cast iron skeleton, connected with flexible interlocking joints that absorb and dissipate seismic shocks. The entire structure is shaped aerodynamically to resist wind and has a low center of gravity for stability. This isn't just a building, it's a machine. A machine designed for one purpose: survival. And it has performed its function flawlessly for almost 1,000 years. When we look at the Iron Pagoda today, we're not just seeing a relic of the past. We are seeing a testament to a lost age of engineering genius, a 1,000-year-old blueprint for resilience. It proves that the line between ancient craftsmanship and modern science is much blurrier than we often imagine. The masters of the Song Dynasty weren't just building for their time. They were building for all time. Next time you see an ancient monument, look closer. Beyond the beauty and the history, you might just find the secrets of a forgotten technology. A story of innovation written in stone, brick, and iron. Thanks for joining us on this journey into the engineering secrets of the Iron Pagoda. If you found this as fascinating as I did, make sure to hit that like button and subscribe for more deep dives into the hidden science of our world. See you next time.